When we get to our next question, which was question number 4, we want the risk difference. The RD between the exposed and the unexposed. So here we have the exposed. Let's use the percents in this case. So we have the 31.3 minus the 11.2, which gives us 20.1% or per 100. I think I'd rather put it as per 100 because we're going to be talking about these as excess cases. There were 300 people on the ship, so 20 per 100, which would have been like 60 cases altogether, would have been prevented if people had not eaten tomatoes. And you can use this in the future, right? If the situation still exists the way it was, you would think, okay, we can prevent 20 cases per 100 people of salmonella if we can keep people from eating tomatoes on salad bars. Of course, that is only true if they don't clean up their act there in that cafeteria. Okay, so the interpretive sentence for this one would be that there are 20 per 100, 20 cases per 100 of salmonella. I'll learn how to spell that eventually. That would be considered excess. In other words, could have been prevented. And this is among the exposed. Right? Because the risk difference compares the exposed and the unexposed and just subtracts. So this will tell you how many more cases there were in the exposed group than there would have had to be. They could have been prevented. And so that's what you're looking for with a risk difference. How many excess cases, how many cases could we expect to save if we had not had the exposure, if we could have prevented the exposure? Okay, so that's the risk difference, the RD. We could also ask the PRD, the population risk difference. PRD, and this one, the PRD, the formula is the risk in the total population minus the risk in the unexposed. So this is a rate we have not calculated yet. We have to use the bottom, the totals row to get that. 60 people got sick out of 300. That's the total rate. So let's figure out what that is. 60, so cancel that. 6 over 30 is 1/5. And 1/5 is 20% or 0.20. Well, let's give it as 20. So that's this rate in the total. Now we're going to subtract the rate in the unexposed, which was 11.2. So 20 minus 11 is going to be 9. It was a little more than 11, so it's 8.8. Yeah, 10 minus 2 is 8, so that would be 9 minus 1 is 8, and then, okay. So this means that in the total population, 8.8 per 100 cases of salmonella could have been, you could round this up to 9 if you want. Usually it's easier to talk in terms of whole numbers of cases. So 9 cases per 100 people of salmonella could have been prevented if those people could have been warned not to eat the tomatoes. This is a lower number of cases per 100 because we're talking about the entire population. If you focus on the vulnerable exposed population, it's a larger number of cases per 100 in that group. But when you look at the entire population, some of whom were exposed, some weren't, you wouldn't be preventing as many cases per 100. It's a smaller fraction of the total population. Okay, so that takes care of the first 5 questions. There were only 2 more, and those were the attributable risk. Let's see, we're going to need this rate in the total. Let me write it up here. Rate in the total was 0.20.